Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle. I'm here with my co-host Gary Lerude. In this episode, we're going to take a look at our October Passive and Control Components issue. Cover story is great, written by Soitec about a new piezo-on-insulator process that they've engineered substrates for our 5G RF front-end filters. And right now, the discrete SAW and BAW filters are meeting these needs, but with 5G, there's really stringent requirements. And this new piezo-on-insulator process can allow integration with switches, power amplifiers, and tuners all on one substrate to give you a really compact module, yet they also meet the needs of 5G. So very interesting to see how this develops. It'll be a big step forward, I think, in the module development.
Yeah, sounds really interesting.
What do we have for technical features?
Well, we have several. Teledyne Storm has written about a new connector series, the 1.35 millimeter. This is designed to be more rugged than the 1 millimeter. It goes up to 90 gigahertz, not quite as high as the 1 millimeter, but it's really intended with this ruggedness to cover the auto radar, the E-band, also the 60 gigahertz unlicensed band. So a number of companies actually were introducing this at European Microwave, and Teledyne Storm has written a nice article about the development. Then we have from Mini Circuits kind of a primer on transformers. I think of transformers as wire wound around an iron core, but there are lots of different variations of that, and it's a good article that talks about that. We have from Anritsu, as you know, they have a new 220 gigahertz vector network analyzer. They talk here about the design of a vector network analyzer that goes up to 220 without needing any frequency extenders, and so that's interesting looking at the architecture of it. We also have from Mori Microwave and the Swiss Federal Institute of Metrology a nice joint paper on characterizing measurement uncertainty in S-parameter measurements. And this is a really key area, particularly if you're doing high volume manufacturing. You need to know what your uncertainties are. And then rounding out the issue, a nice overview article from Hughes Network Systems on some of the design considerations for high throughput satellites. Here they're looking mainly at the links between the ground station and the satellite and back, and how do you get really high reliability for high broadband speeds. So as always, a very interesting issue.
A lot going on.
Yeah.
So turning to the news, the Singapore MIT Alliance for Research and Technology, or SMART, announced that they've developed a process to combine silicon devices with 3,5 compound devices, giving you the ultimate in performance. And I know DARPA and some of the defense companies have worked in this area, but this is going to be a commercially viable process. They process the silicon with 2 layers and separate gallium arsenide or GaN devices, and then they integrate them vertically, so it's kind of a 3D integration with better than a micron alignment. So I think this will be really good potential. It'll be available next year for commercial uses, and following year they hope to go into high production. So it'll be interesting to see if this really is realized.
Yeah, as you say, I've heard a lot over the years about people that have done research in this area, but it sounds like this is the first one that's actually going to get into commercial production.
What did you see in the news?
Well, I think the big news this week was Qorvo's acquisition of Cavendish Kinetics, the MEMS switch manufacturer. This will bolster Qorvo's portfolio for mobile. Cavendish was focusing a lot of their efforts on the mobile applications, particularly antenna tuners. So I think we've seen the evolution of switch technology beginning with MESFET and then PHEMT and then silicon on insulator. I think this may be the next generation because MEMS switches, of course, have low insertion loss, they have high isolation, they have high working voltage, which is important for antenna tuners. And so we'll see how this develops. It's interesting also, Qorvo didn't say what the deal was in terms of purchase price and so forth, but it was disclosed that Qorvo and also Qualcomm were strategic investors in Cavendish. So it's a logical next step, and they obviously feel like the technology is ready for production.
So turning to events, we just returned from European Microwave Week in Paris.
Yes.
A very successful event. Attendance was near record levels set in Madrid last year, and exhibition space was a record, so they did really well with that. This year they added an automotive forum, which had more than 160 attendees, so they were very happy with that. And we helped with the Defense, Space, and Security Forum again,
right.
And that had more than 150 attendees too. And we did the Lunch and Learn session with Strategy Analytics, and then we had our industry session with Qorvo, OMIC, Rohde & Schwartz, and NI presenting on advanced radio architectures for SATCOM applications. So it really went well. I'll try to post those presentations in about a week from now.
Yeah, it was a really good presentation.
And then turning to the exhibition, a lot of interesting products there. On the test and measurement side, the companies are really doing a good job of making wider bandwidths and higher frequency systems being driven by aerospace and defense, automotive radar, 5G, SATCOM. We saw Keysight and Rohde & Schwarz presenting 5G OTA test systems. Rohde & Schwarz has a compact antenna test range that can even do temperature testing. So that's the first one I've seen that can do over temperature. And then Keysight has introduced their 110 gigahertz oscilloscope into the system. So now you can capture any frequency of interest over that band, which is very unique. And talking about pushing the frequency up, you mentioned Anritsu has a 220 gigahertz VNA. They've upped their portable model to 170 gigahertz. And then NI has teamed up with Virginia Diodes to extend their test system to the terahertz range. So now they're even going into 6G and beyond research. So a lot going on with test and measurement. On the software side, we're seeing the same type of drivers, and they're doing more simulation for antennas and phased array systems. So you see Keysight, NI, AWR, ANSYS, REMCOM, ComSol, MathWorks, to name a few that we saw at the European Microwave Week presenting that type of technology.
Yeah.
What were some of the products that you saw?
I think this year is the year of the 0.15 micron GaN.
I agree. I noticed that.
Yeah, we heard from UMS. They've released a process. WIN has released a process. They have sample kits that are available. And then also Wolfspeed said they have fully qualified their process. So those three companies joined Qorvo. I think their process has been out for a while. But now there's a huge portfolio people can choose from if they want to take GaN into the millimeter wave spectrum. And all of the processes have very respectable performance. The other thing we saw, WIN, speaking of WIN, celebrated their 20th anniversary, or they had a party to celebrate it. I think October is actually the 20th anniversary. But who would have imagined in 1999, when they started as a open foundry, that they would grow to be now the world's largest compound semiconductor foundry?
Yeah, that was very unique back then.
Yeah, exactly. So a lot of success there and a lot of hard work on their part. The other thing, and I may have said this when we recapped IMS, but I continue to be very impressed with NXP. They were quiet for a while they were being acquired, which never happened, but they've developed a nice portfolio. So they're continuing to use LDMOS and GaN for the base station infrastructure side, particularly now products for 5G. And then their silicon germanium process they're applying to the millimeter wave 5G bands. So beamformers, and they've got some other products under development. And then I also saw, and this may have been at IMS as well, but they've done front-end modules using this process for the 2.4 and 5 gigahertz Wi-Fi 6 spectrum or standard. And they've even extended that now to 7 gigahertz. They said they're sampling some customers with that broader band device. Wow. So nice work on their part. I think they have a nice portfolio. So that's about it. I think on the millimeter wave side, we did see, again, a lot of on-wafer probing. That's going up into the terahertz region. And so there's quite a lot of development there as well. So I think that wraps it up.
It does.
So we want to thank you for watching, listening to our recap of the issue and the European Microwave Show, also industry news. We want to thank our sponsor, MACOM, for making this possible. Remember, MACOM is your partner from RF to Light. Until next time.